Today, we're going to look at something called transformations of graphs, the shift of graphs, okay? And that is basically just saying how the graph moves, all right? So, here's what I'm talking about. You guys have just a regular old function, okay? Your regular old function is f of x, all right? That's your function, but you know what? I wanted to mix it up. So I took a number and I added it to the back of your f of x. Do you see that? Do you see how it says f of x, what we had, and then now I put a plus k? Well, you know what happens? When I added the plus k at the end, it moves it up k units. So if I said plus 3, then it moved it up 3. Okay? Now, how about this? How about if I took a minus k and I put it at the end? How do you think that moves? Yeah, down k. There you go. Can you see it? You can see it, right? Man, so much for the surprise. Just play along with me, okay? So, okay, then that was k on the outside. Now, you know what? I'm going to take h and I'm going to put it inside the parentheses with the x. So now I have an x minus h. Wait a minute. If I have an x minus h, that moves it to the right. Huh. Minus h, I would think, well, that's a negative h, right? So that should go to the left. Whenever it's inside with the x, think opposite, okay? So then if I have an x plus h, then that has to move how? Yeah, left h, all right? All right, so look at the next one. What happened to the next one, guys? What do you see? Yes, the negative, thank you. There's a negative in front. And if you have a negative in front,
It goes on.
that's a good guess. So look, it flips or it reflects. So if it was up here, it flips and it moves down. Okay? So it either flips up or down across the x-axis. All right, so for the next two, you know what? It multiplies by a. There's a number that's going to be multiplying in the front, okay? If that number is bigger or greater than 1, so give me an example. What's a number that's greater than 1? 2. So you could have 2 times f of x. You know what? Can't we write a number bigger than 1 as a fraction too? How? Give me a fraction that's bigger than 1. Good. 13 tenths. 5 over, what did you say?
1.
Okay, but give me another smaller number under.
5 over 4.
Okay. So you could say 13 tenths f of x. You could say 5 over 4 f of x, right? Don't let those fractions make you think that it's less than 1. Sometimes they'll write a fraction that is bigger than 1, right? So when this happens, when that happens, guys, when you multiply by a number that's bigger than 1, it stretches. And I want you to write just that. Just write stretches. Don't worry about all this. I try to delete it, and I can't. It's too fancy for me. Stretches. But if you multiply by a, and your a is between 0 and 1, can you give me a number that's between 0 and 1? 0.1. Well, that's a fraction and it's bigger than 1. Give me an example of that fraction.
Like half or
Good.
quarters.
1/2 f of x. Okay, right?
3/4.
You said what? 0.1, which is 1/10. Right? All of those fractions where your top number is smaller than your bigger number, right? I mean, than your bottom number, sorry. Then that means that it's less than 1. And when that happens, it compresses. Okay? So I'll just put compress. That's what happens. It compresses. So stretches means that it gets narrower. Like you stretch it out, it gets all, okay? Compresses means that you smush it down so it gets wider. Okay? Wider and maybe a little bit flatter. Alright? Okay, questions about this? Refer to this when we look at
So the compress is wider and the stretch is
narrow, more narrow. Alright, so let's look at the next part here. And you know what? You know what I actually want to do? I want you guys to go to the back, please. Let's start with this. I think this makes us flow a little bit better. Okay? So go to the back, and you're going to look at, I think it's number 10 on yours.
yeah.
Okay. It says number 1 on mine, but on yours is 10. All right. So what it says is, how does the graph g of x, how does this, what they gave you, shift from the parent function f of x? How did it move? So your basic equation is this guy, f of x. All right? So for number 10, I'm going to see what stuff was added on. Okay? So I have, wow, there's a lot. I got this, and I got this. Do you agree? Those are all the extras, right? So let's talk about what each one of those means. This plus 4, how did it move? If I have a plus a number all the way on the outside,
To the left.
it went what?
It's to the left.
Ah, is it left? Plus 3. How did that one move?
Opposite the nose of the
Ah, yep. And you know, and that's the thing is that be careful. It's not inside the parent. Oh, you were talking about this one. Then I'm sorry. Talking about this one plus 4. Sorry. Okay, we were talking about different things. All right. So plus 4 means that it goes how? Up 4. All right. You weren't wrong. I just wasn't there yet. I'm sorry. Okay. So then what about this x minus 3? To the right 3. Good. Because this x minus 3, it goes right 3. And what about this guy, the 2? Your a is bigger than 1. When it's bigger than 1, what does it do? Look on the front if you need to, okay? Look at that table. What happens when your a is greater than 1?
Stretches.
Stretches, thank you. Right? Are we okay with this? Can we try one more? 3 more? All right. So this one, okay, this is a little bit weird, guys. We have a negative. It's not -3, all right? It is a negative and it is a 3. They have 2 separate jobs, okay? So we have a negative and we have a 3 and we have a +1 inside the parentheses with the x. So tell me, what does this negative do? Good. It reflects or it flips. And, you know, on the SOLs, they'll use reflects. If you guys write flip, that's okay. I'm not going to mark it wrong, okay? But just remember that reflex is also what that means. All right. What about this 3 right here? Plain old 3, multiplying in the front.
Stretching.
Thank you. Stretches. And what about that +1 that's inside with the X? Left one. Good. Thank you. Perfect. How is this? Isn't this so fun? Man, look at all of the stuff that you guys told me about this equation, and we didn't even have to graph it. All you did was just look at the equation and you knew, right? So let's look at 12 and 13. No, 13 and 14. Is that what you have? 10, 11, 12, 13. You know what? I'm not feeling very well today, so I'm sorry. I promise. I'm going to get the math right. I'll get the other little stuff like the numbers wrong. All right. So, what did we say? This was 12? All right, let's look at this guy. What are the 2 changes, the 2 shifts that happened here? Okay, that one and that one, right? Oh, you're going to just tell me the answer? Okay, hold on. So this one is down 6. And how about this 1/3? Compress? Do you agree? Is that one compress?
Yeah.
Yes. It compresses. Okay? All right, so I want you guys to look at the next one. Try this one on your own. I want you to write down the 3 transformations and tell me what they are, okay? All right, we're ready. Stretches. Yeah?
Yeah, it is.
Okay, what about this one? Right 3. Can I get a yes or no? Do we agree?
Yeah,
Yes? Okay, Ethan, you're on the roll. What else? Yeah? Yeah? Okay. Super. Great job. Cindy? Yeah? All right. Perfect. Good job. Great job, guys. So now you've shown me that you can write down the transformations, right? Now, can you graph it? Okay. Now let's go back up to the front. Right underneath our table. Let's go to the graphs. Let's graph these guys. This is where I want you to use your color pencil, please, so that we can draw our new graph in a different color. If I look at number 1, f of x plus 1, how did this move? Yeah, up 1. Good. So here I'm just going to put up 1. All right. And then I'm going to grab my color. Okay. So what you're doing is you're basically taking every single one of these points and you're doing what transformation, it says to do. So this one says up 1. So this guy is going to go up 1. Yeah? So then look at the next one. This B down here. Oh no. Not the highlighter. Sorry. Okay. This one, I have to go how? Up 1. Okay. And then this guy, I have to go up 1. And then the last one also has to go up 1. Okay? And then connect the dots. You must connect these dots to show me the graph. There we go. So good, right? Okay, let's look at the next one then. Amner, can you tell me how the next one Down 2. Can I put D2? Okay. And then how? Because I see another transformation. That one's your down 2. What about this guy? Let's see. Sabrina, do you agree? How does this one move? Help out, Abner. X plus 1 inside the parentheses. Does it move left or right? Good. Left. Left 1. Remember, when it's inside with the X, right? Inside the parentheses with the X, Abner, you got to think opposite, okay? All right, so now, guys, each point has to move in 2 different ways. Down 2 and left 1, okay? So then this guy has to go down 2, left 1. Okay? And then this one. Oh no, why does it keep going to the highlighter? Am I? Oh, there we go. Down 2, left 1. Okay. I see you guys are all doing it on your own, so I will leave you be to do that. Down 2, whoop, left 1. And then please don't forget to connect your dots. There we go. Does your graph look like mine? Did I do this right? Listen, I've been messing up my numbers. You guys have to double check, make sure I'm graphing this right. Okay, so how many of you guys are like, you know what? This is getting too easy. Kevin, I feel like you're like, it's a little easy. Yeah? Am I wrong? How is this? It's pretty good? Sabrina? It's all right. Okay. Timlin, how is this? It's all right. Okay, well, you know what? I'm going to make it just a little bit more interesting. Look at this next one, number 3. If you have a negative in the front, what happens to it? It flips. All right, we're going to graph this guy. So what am I doing? What am I writing in this? Oh my goodness, what's happening? Okay, so it flips. So it reflects.
Over which axis?
Or it flips. And it reflects over the x-axis. So here's the easiest way that I found, okay? Go to each point. We're going to see how far it is from the x-axis, just like you did in geometry, okay? That guy right there is actually on the x-axis, so you can't flip it. If it's right on it, it just stays there. Are we okay with that? All right. So then let's look at this guy right here, right down here. Okay. This point, you guys, is how far down from the x-axis?
3.
1, 2, 3 down, right? So if you want to flip it, you have to flip it 1, 2, 3 up from the x-axis. Does that make sense?
Yeah.
So from right here, you gotta go 1, 2, 3 up, and there's your new point. Okay. So then this guy, the next point is 1, 2, 3 up. So now I have to go 1, 2, 3 down. And then this last point is 1, 2, 3 up. So I have to go 1, 2, 3 down. Okay, good. And then don't forget to connect your dots. And look at how pretty that looks. Oh, sorry, my line is a little bit uneven there. How is this? Good. Huh? All right, let's try some more. So the next one, okay, we have 2 transformations. What are they? right 2, and what is this negative in front? Reflects, right? It flips. All right, whenever you have a reflex with another one, always do the flips first, okay? All right, so this one. The first one is right on the x-axis, so we said it can't flip, right? Just stays there. Now do your right 2. So it goes right, 1, 2. Okay? So then this guy down here, since it's down 3, if I flip it, it goes 1, 2, 3, up 3. But I also have to do what? 2. So 1, 2. There we go. Are we okay with this one? Okay, so you guys try this. So walk around. All right, I'm gonna put my graph up here. Finish this one. Since it's up 3, I go down 3, and then right 2. Here I am. This one, down 3, right 2. There we go. Yeah. Okay, so I'm gonna look at the next one. The next one is, let's see, it's also a reflex or flips, right? And then this one is a down 1. Okay? If you're still working on it, that's fine. Keep working. All right? If not, we can do it together. This first one, we can't flip it because it's right on the x-axis, right? But I can go down 1. So there you go, right there. Right? For that first point. So this point, since it's down 3, when I flip it, 1, 2, 3, it goes up 3, but I also have to go down 1. So there we go. And this next point, since it's up 3, when I flip it, it goes down 3, but I also have to go down 1. So there I am. Okay. Yeah? All right. And then the last one, that guy is up 3, so I have to go down 3 and then down 1. Okay? And then I need to connect. There we go. How are we with that? Should we look at the next one? Are you guys ready for the next one? Okay. So the next one, what a way to put 2 not as easy transformations together to graph, huh? All right. This negative in front tells me that it does what? Oh, remember, the negative and the number are different. So you're right. Ethan says that 2 stretches. But what does the negative do? Good. The negative flips, right? So it reflects. So it does both. It's going to flip it and then stretch it. What does that mean?
You reflect first.
You always reflect first. So when it stretches or compresses, guys, all you're doing, remember how we counted how far it was from the x-axis, right? You multiply how far it is by the number. So if that was a half, you would multiply by a half. Since it's a 2, we're going to multiply it by 2. Okay? So let me show you what this means. That point right there, can I flip it? Stays the same, right? Because if it's right on the x, you can't flip it. But think about it this way. How far is it from the x-axis? Is it far from it at all? No. So if you had to put a number on it, what would you say? that it didn't move from the x-axis? Okay, so how would you say, like, it doesn't move, there's nothing? What number tells you nothing? 0, right? So this one is basically 0 spots away from the x. Does that make sense? So what's 0 times 2? 0. So you know what? That one just stays. Okay? Now let me look at this one. So this one is 1, 2, 3 down, right? So if I flip it, it has to go 1, 2, 3 up. Do you agree?
Yeah.
But guys, what is 3 times 2? 6. So that means instead of going just 3 up, I have to go 6 up. So 1, 2, 3 again gives me 6. There we are. Does that make sense? So then I'm going to take this guy, and if this guy is 1, 2, 3 up, then I have to go, what's 3 times 2?
6.
So 6 down. 1, 2, 3, 4, 5, 6 down. Wow. You see how it like stretches right now?
Yeah.
See how far it is. So then let me do that last one right there. Since it's 1, 2, 3 up, well, 3 times 2 is 6, so I have to go 6 down. 1, 2, 3, 4, 5, 6. Are we okay with that? All right, and then connect the dots and let's see what this stretched out graph looks like. Oh my, I'm sorry. You know what? That is so messy. I don't know what happened. Okay. Try it again. There we go. All right. Okay. Questions? All right. Guys, can you do number 8 for me, please? Try number 8 on your own, and we'll try 7 and 9. So number 8, you should have, it went down 3 and right 1. Do you agree? Okay. So if I take every single one of these points, let's see, down 3, 1, 2, 3, right 1. There we go. And then this point should be down 3, right 1. Yeah? And then this point, down 3, right 1. And then that point, down 3, right 1. That's what my graph should look like. Yeah? Okay. Sounds good. Suman, you got this too? Ethan? All right. Evan? Tom? Okay. Sabrina and Abner? Yeah? All right. Okay, so let's look at number 7. Number 7. So, Abner, tell me the transformations that happened here. This 1/2. Okay, so it compresses. And what about this +2 inside with the x? Good, left 2. So, guys, whenever you have a number that's in front, you're just multiplying it, right? With how far we are from the x. Okay. So what I'm going to do is I'm going to take this first point. Guys, how far is it from the x again? What do we say about this guy? 0. What's 0 times 1/2?
0.
0. And then go left 2. Okay. And then let's go to this guy right here. How far are we from the x? 1, 2, 3. What's 3 times 1/2? What's half of 3? Yeah, 1.5, right? So that means I have to go 1.5 and then to the left 2, right there. can just eyeball the half. Does that make sense? A little weird, right? Yeah. Well, let's go to this one. Okay, so right now we are 1, 2, 3 above. What's 3 times 1/2? 1.5. So that means, okay, only 1.5. And then what else do I have to do? Left 2. So like right there. Yeah? And then I'm going to look at this guy. And this one's the same thing. It's up 3, right? So then that means half of 3 is 1.5. And then left 2. So right there. Okay? And then connect your dots. Oh my goodness, look at that. It compressed, right? It's a little bit flatter, I guess. So guys, do you want to try number 9? All right. It stretches and it goes how? Up 3. Good. So it stretches and it goes up 3. Do the stretches first. All right. Multiply by 2 and then do up 3. Okay, so let's go over this one. Stretches and then up 3. So this first dot, since it's right at the x-axis, we can't stretch it, right? 0 times 3, or 0 times 2, 0. Up 3, so 1, 2, 3. Yeah? Okay, so the next one, this guy. So if I stretch this, it is 1, 2, 3 down. 3 times 2 is 6. So now it's 6 down, right? But then we have to go up 3, so right back to where we started, huh? Yeah. Okay, so let me look at this one. Uh-oh. Okay. And then this one. So stretches, so times 2. It's up 3 right now, so now I have to go up 6. But then I have to go up another 3, way off the charts here, right? I'll say about right there. Does that make sense? Okay. So then the next one is this guy. And since it's up 3 times 2 is 6, and then up another 3, so about here at 9. And then if I connect the dots, oh my goodness, look at this guy. Stretches and then up 3. Did yours go off the charts too? Should have. Good. Do we have any more? Oh my goodness. Just the challenge one. All right. You know what? I want to try a challenge one with you guys. Okay. Yes. Do you have a question? Tom? No? Oh, so you had your hand raised. Okay. So let's look at the challenge questions down here. It says, what is the, and guys, I'm not going to test you on this. I just want you to try.
That's what I was gonna ask.
Okay? Oh, well then why did you ask it?
Well, because I thought we were gonna adjust it in a minute, so I wanted to wait.
Well, I'm not going to test you on this, but I do want you to try it, okay? It says, what is the equation of the solid graph if you start, right? If it's a parent graph where you start, is the dotted one. So you're going from dotted to solid, okay? Keep that in mind. Yeah? So my dotted, you got to find the matching point on the solid, and you got to see how it moves, okay? First off, I want you guys to look at the overall shape, and I want you to make sure that the shape is the same. And don't write this, I want you to just see what I'm doing. The dotted one goes like a V and up, right? Does the solid one do the same thing? Solid one, V and then up? So, did it flip? No. If it went from a V to a, what is that? Like a cone? TP? Right? Then I know, oh, it flipped. Because it's like opposite, right? Okay. So I will go from here to this guy. Because that's the matching point on my solid one, right? How did it move? Up to. Is that it? Yeah. So let me check this one just to be safe. This one too went up to. Good.
So it's g of x plus 2.
So it is g of x, because it tells you what that is, right? The function. And then up to, so it's plus 2. Yeah?
Yeah.
Okay. Let's look at the next guy then. Alright, the next one, these are both v's, so it didn't flip, right? Okay. We're going from the dotted to the solid, so I'm going to start with the dotted here. And how did it end up over here? Is what? Reflects? Okay, that's what I was talking about. It only reflects if it goes from this shape to like that shape, right? But remember how in the beginning I double checked? I want to make sure it goes from a V to a V, so it doesn't reflect, okay? We're going to see how it moves. So from here to there, let's see, it goes down, was that 2? Down 2. And then 1, 2, 3, 4 to the left, right? Okay. So how do we write that for this h of x?
Hx plus 4 close parentheses minus 2.
Plus 4, close parentheses, minus 2. Good. Perfect. Good job. All right, Timlin. Now look at this one. Your dotted line goes at like a V, right? But look at your solid one.
It flips.
This one flips. So with this one, I know it flips. I'm going to put that on the side. Reflects. Okay? And then let me take this guy, this point. How did it get from here to here? That's the matching point, right? It went to the left. 1, 2, 3. And then how? And then how did it go here? Up 2. So how do we show that? How do we show left 3 and up 2 for j of x?
Negative j x plus 3 close parentheses minus 2.
X plus 3, close parentheses, and then up 2 plus 2. Yep. Good. How was that? That's pretty fun, isn't it?
That was good.
All right, so you guys have homework E. Next class, if you guys check on your assignment sheet, you have a test. It's the Unit 1A test. Please make sure that you guys do this review, okay? This review is a review for your test, all right? I'll put up the answers to the review, just the answers, up on Blackboard. Remember, you're not going to get anything out of it if you just copy the answers, right? So really try this. If you have any questions, make sure you go back and you listen to some of the lessons. If you go on Blackboard, I have all of the completed notes that are copied there too, okay?